Hello, everybody. Hi, my name is Mark Miodownik, and I am the chair of today's meeting, which is to launch this amazing report on critical materials. And I can see that you're all absolutely going to be fascinated by what this report and the discussion around it is going to kind of reveal to you today. My fact of the day about electronic waste in general, and about our need for critical materials, is that by 2030, the UK will require access to 40% of the current global supplies of lithium to meet its net zero needs. So just the UK, 2030, which is not very far away, we're going to need what is current 40%. And then there's all the other countries doing the same thing. So these discussions about critical materials are critical. If we want to do what we say we're going to do, which we have to do, as we all know. I want to just say, as a material scientist myself and a long time sort of just lover of materials, how, it is just worth noting that until relatively recently, materials were the most important thing to society and civilization. Like, the ages of civilization are named after them. We have the Stone Age. You don't get to the Copper Age unless you can work out how to change rock into copper. And as soon as you can do that, which is a miracle, and what a moment that must have been. Imagine that moment, right? We think it must have been around a fire somewhere near a deposit of copper sulfate, perhaps, or copper minerals in some way. And some of that ends up in the fire. And then at the end of the fire, someone notices that there was a reduction atmosphere, or maybe they don't use those words, and that there are these little glints of copper. And they think, it suddenly dawns on them that all the rocks around them might contain metals. And they start using the copper, and they start using it for tools. And it's the perfect tool material metal because it's repairable and it's reusable, and you can hand it out. It sort of almost lasts forever. And so the Copper Age starts, and it just opens up a whole avenue. The pyramids are built with copper chisels. Architecture, boats, global trade. The exploration of the whole world. And we get the Bronze Age, and then we get the Iron Age, and we get the Steel Age, and this is how we are here today. If you think about our lives without materials, all of them around us, we're naked, we're shivering in an October, quite drizzly, cold day. We can't survive, is the truth. So materials are everything for us, and so it always gives me so much pain when I go and visit, places where, dumps and tips, and where they're just being thrown out and we're just so profligate with materials now. And it's relatively recent that we've been so profligate. And of course, that is really because, not because materials are any less important now than they were. It's because we've actually kind of found a way of really efficiently extracting them and making them, because we've fallen in love with so many different types of material. And we just, we're really, enjoying them as a society. But what we don't seem to enjoy is reusing them, recycling them. And that's partly because of the economic model in which we produce them in the first place, in which they are not valued as waste. And we want really to kind of shine a light on that today and highlight where this road of creating waste and disposability is leading us, and how it's such an crucial that we can do something about it if we're going to address global problems of climate change, pollution, and all biodiversity. So that's just setting the scene. You all know that anyway. You wouldn't be here otherwise. But it's always good to kind of just remember where we've come from. Okay, so let me give you an overview of the agenda. So in a minute, in less than a minute probably, I'm going to invite the report working group chair, Professor Joan Cordiner, to come up and present the report findings, and there'll be a short Q&A. And then we're going to get a brief presentation on a case study from Dr. Charlotte Stamper, from Energy Infrastructure Lead at European Metals and Recycling, and she was also a member of the working group for this report. Then we're going to have a panel discussion where we discuss issues around the report and the findings with you all, and that's going to include Dr. Colin Church from IOM3 and Libby Peake of the Green Alliance, with the other two speakers. And then there's going to be an announcement of upcoming publications, followed by an opportunity to network and have drinks after the event. All of that in an hour. That sounds good, doesn't it? So without further ado, I'm going to introduce the working group chair, Professor Joan Cordiner, who is a professor of process engineering at the University of Sheffield and head of their School of Chemical Materials and Biological Engineering. Having previously had a distinguished career at Syngenta across senior and global management positions, leading changes in design practices as their leading industrial researcher, she also holds fellowships at the Royal Academy of Engineering, the Royal Society of Edinburgh, the Institution of Chemical Engineers, and the American Institute of Chemical Engineers. And she has led the production of this report over the last year and will now present its findings. So.
Thank you so much for the introduction. So we started just about a year ago thinking, what's missing? And we discovered that the whole demand side of critical materials really hadn't been touched. The government has a critical mineral supply strategy, and that only gets us so far, because if you just heard 40% of lithium just for the UK, well, we ain't going to get it, right? Because there are bigger countries out there who also need large amounts of lithium. So we have to address this for the UK, for jobs in the UK, but also for our economy, for our well-being. I read about a year ago the book by Ed Conway, Material World, and if you haven't read it, I would highly recommend it. It goes through, just like our chair did, how materials have changed our world and how much of an impact that they have on us, and the scarcity or the lack of these materials can have a huge impact. It's not only the fact that we won't be able to get them, potentially, but also we need to change our design processes. We need to think about the issues that are caused by materials, by how they're extracted. My dad was a mining engineer. I grew up seeing the detritus of mining. And of course, it's not on our doorstep anymore. It's not coal mines in the UK. It's lithium mines somewhere else in the world. It's cobalt mines, zinc mines. But that's having a huge impact, ecological impact, and on the lives of people. There is no joined up strategy in the UK for materials demand. We have a huge lack of data. We don't know where our materials are. So just now you're all holding some critical materials in your pocket. You probably each have at least 2 devices, if not 4 or 5 or 6 or 10 in your house. Then there's all these e-vapes that are suddenly appearing everywhere. So if we don't do something now, it'll be too late to be able to extract all these critical minerals that we can then reuse. It's almost like our bank within the UK of these critical materials. If they're here, we want to keep them here and be able to reuse them here. But at the moment, if they are recycled at all, it's done offshore. And that means our critical supply is not here. So we need a strategy. And so what we decided a year ago, we would look at how we could bring together diverse policy areas and how we could meaningfully respond to this and look at what we can do about it. What are the solutions that we can do now? So demand is fine, but it's how we manage it that matters. Over the next 10 to 20 years, we will be building infrastructure for net zero, probably more change than has happened in the last 20 or 30 years. And that once it's built, most of that infrastructure will last for 20 plus years. So we're making decisions today that change in the future what we'll be able to recover and what we'll be able to recycle. You see you'll hear about windmills just now and how can they be recycled. All of our electronic vehicles, sorry, not electronic, electrical. It would be much easier if they were electronic, there'd be a lot less energy. So we need to think about the design now. We need to think about what infrastructure we put in now, because that will have a lasting imprint. It also will have to think about how we build things just now so they're easy to recover. If you look at recycling batteries just now, you've got hugely toxic processes. They're incredibly complicated. It's not easy to break them apart. And of course, every new battery is slightly different. So how can we change the design process? How can we change policy? How can we change standards such that we have a way of improving what we're going to leave ourselves with? So infrastructure is really the heart of this. If you think about the amount of change that is going on in our energy systems, just think about copper. We heard about copper earlier. Who knew that copper would be so important? But copper is in electricity, right? So in order to upscale the grid, which we hugely need to be able to rise to the needs of net zero, we need an enormous amount of copper. Well, maybe you think copper's not that critical, but it will become critical. Now that might be easier to recover than neodymium that is in the magnets that are in offshore wind, but we need processes to do all of these, particularly obviously the critical materials. We also need to think about what energy do we need. At the moment, you can wash your clothes, make your dinner at whatever time, day or night. If I lived in Switzerland, which I did at one point, I got told what time I could do my washing at 10 o'clock in the morning on a Wednesday, but by the way, I would be working then and I had 2 small children. So it was a bit of a problem. But if other countries can find ways around it, we can. We're just used to doing things the way we do them. When I was a little girl, my mum did the washing on a Monday shared with lots of other women who worked together. So we have ways, some of you who are my age or older will remember our returnable milk bottles, will remember being taught how to repair your car. I wouldn't dare touch my car today because there's so many electronics in it. But should we be making different design choices? Should we be putting policy in that makes car makers, electronic makers do things differently such that we can repair, not just throw away? What about modal transport? When I was in Switzerland, I didn't have a car. There was no need for a car. I could rent a car at the weekend if I wanted to see some mountains. I lived in Houston. Obviously, I needed a car there. We can make decisions now that make active transport but of course it's not just London. London's easy in comparison, right? We have all the transport. But most of the country doesn't live in London. So what decisions are we going to make in infrastructure now so that people will choose to use transport that will use less electricity, less energy, and therefore we can reduce demand? Digital infrastructure, the rise of AI. If you are to look at graphs and in the reports about the amount of energy that AI is taking, instead of reducing our energy demands, they're going up. Our infrastructure demands for net zero means infrastructure demands are going up. So most of the rise and need for critical minerals are actually something we can control if we do it now. And of course, it wouldn't be the Royal Academy of Engineering if we didn't say that it needs a systems of systems approach And of course, who are the best people to do a systems approach? It's engineers, right? So, but that is all going to be made easier if there is data. And so that's why we're calling for a system to capture data, to know where it is, a materials passporting system, if you like. So in the report, you'll see an awful lot of detail. The team have done an absolutely fantastic job, and I really want to thank Isabella and Kane, who have done the lion's share of this work. They have, please give them a round of applause. I always feel a bit of a fraud at these things because they do all the work and we get to stand up here. So what we can see from the report, from all the data in the report, and I really implore you to have a look at the details, is we have to do something now. If we even wait 3 years, we'll lose a third of the benefit. You know, people say we need to get on with net zero. Well, it's not that we need to get on to, we're already past when we needed to get on to it. And if materials are critical and to our future jobs, our future ability to have energy, to have the lifestyles we want, then we need to have a joined up strategy now. We have to have something that drives the right decisions, because economics are not driving the right decisions just now. So should we substitute sodium-ion batteries instead of lithium? Should we have more cobalt or less cobalt? What are the parameters or the push, whether it's policy, research, funding, to push us in the right direction, to push policy on life extension, repair and reuse, and obviously designing for end of life. If all batteries were made in such a way they were easy to disassemble and they were all made within a certain realm of process that can be recycled in the same factory, then we can invest in this country and be able to recycle materials here. At the moment, we're not recycling many materials at all in the UK. So we need eco-design regulation extended. We need strategic production of engineering standards that will help drive the right behaviours, and a greater focus on eco-design as we upskill people in our university courses and our apprenticeship courses and with the general public. So part of the report is an EV battery analysis that the team did, and you can see the lithium demand is just huge. A 30% reduction in larger battery categories would save 75 million tonnes of earth. Now, if you think of that, that is enough to fill Wembley Stadium 19 times. I'm not a football supporter, so I can't visualise Wembley Stadium, but hopefully some of you can. It's an enormous amount of rock. But what is even worse is all the water and all the solvent and all the toxicity that spreads in the area. And, you know, if it was done in the UK, it would be under certain regulations. But we know that's not true elsewhere. So the impact is vast, and I think we owe it to the world to do something about it. And we can call on our government. We know that they can put limits on what can be brought into the UK. We know, for example, cars have to be made of a certain amount of recycled materials. So let's push that further to make sure it's joined up and the policy is joined up. So we want standards for recycling. We want to have the UK really look at how we can invest in recycling facilities. We won't be able to do anything short term because, of course, your batteries are going to take time to build up. But if we don't do something now, we won't have the infrastructure, we won't have the designs that make it easy to recycle. So it's really important that we act now. So hopefully we've been able to convince you, and certainly once you read the report, I am absolutely sure you'll be convinced that we need to do something now to bring in demand-side measures. We need joined-up policy. It's going to have a huge impact on global sustainability and the environmental impact that materials extraction causes. We need to have data to have joined-up thinking. We need to have policy that is joined up because, of course, materials sits across just about every part of government. And unless there's this joined-up thinking, we're not going to have the design, the planning, and the policy to help us make the changes we need to do. So thank you very much for listening. I'm going to invite you to have any questions, and then once we finish with questions, Charlotte will come up and give us a case study on wind recycling, wind infrastructure. Thank you very much.
There's one over there, yeah.
Thank you. Thanks for the presentation. Really interesting. I just have a question. And oh, sorry. Yes, my name is Carla Cervantes Barron. I'm a senior research associate at the University of Cambridge. I have a question that seemed quite obvious to me with hearing this presentation, which was around innovation and the design for batteries that is now like really high up in terms of innovation and investments there. With this proposal, there may be a stifling of that. So do you have a recommendation or ideas on how to balance that?
So as somebody who spent most of her life scaling up processes, what I can tell you is amazing, wonderful chemists and materials engineers work in their lab and they come up with the next best little change that makes everything wonderful. Well, that's great, but we have to be able to scale it up and we have to be able to recycle it. So how do we get the people in the labs who are coming up with the new wonderful battery to think about recycle, to think about how it's going to be recovered, to think about how it's going to be disassembled? And I think that's something that we can educate people around. Now, what we don't want to do is stop innovation, because clearly, if you look at solar, 10 years ago, solar was not economic. I mean, it was put up there because of subsidy, right? But now the change in efficiency in solar is enormous. So we don't want to stop innovation, but we can educate, we can put frames around it to try and encourage innovation that also considers material demand. We can put innovation in alternatives. So when people are deciding what grants to submit, grants to fund, we really need to look at not just lithium but sodium or something else and. And I think that's educating the EPSRC, the UKRI, Faraday, educating government about this whole problem, because it's a systems problem. It's not just a lab problem. Does that make sense?
Thank you. I think we.
Okay, thank you. Charlotte.
Charles, other questions when we get to the panel, if that's okay with it on, but just want to make sure we give little cake stuff. So thank you very much, Joan.
Good evening, everyone. My name is Charlotte Stamper and I am Strategic Partnerships Manager at European Metal Recycling. We're the world's biggest metal recycling company, and my day job, I take apart wind turbines. So I was really delighted to be asked to contribute to this report. Now, the crux of the report is talking about demand reduction, and renewables and clean tech are completely reliant on critical raw materials. So actually, for me, demand reduction and renewables, they actually sit as quite uneasy bedfellows. And I just wanted to really address that to start with. Decarbonisation is not optional. We have to do it. As Joan said, we're on the way, but we have to do it bigger, quicker than we are at the moment. We have no choice if we want to really limit to whatever extent we can the irreversible climate change, the path that we set. But having said that, there are many different ways to meet net zero, and some, coming from the renewables background, it's actually very rare. And Lorna, who's sitting in the room, also works on this topic as with me. It's almost never mentioned when you're at a renewables conference, this idea that renewables infrastructure doesn't just materialise out of thin air. Like everything else, it has to be made, it has an impact, and we have choices about how we do that. And given that renewables are going to be an absolutely fundamental and critical part of the transition to this brave new world that we're on, I think it's absolutely right and actually long overdue that we're asking questions about how we do this. And that, like Joan said, there's some very real choices we need to make now. And I think we should be absolutely leading from the front in the UK on how we do that as well. So just wanted to spend a few minutes talking about offshore wind in particular as a case study from the report. So I love wind turbines, but I'm going to try and keep this very succinct, otherwise we'd be here all evening. Offshore wind is a fabulous technology. It will be a cornerstone of the global push to net zero. And offshore wind turbines are huge. If you've seen ones on land, you ain't seen nothing, because the offshore ones are as big as the Eiffel Tower. I love this picture that I've put on the left. So those are 10 megawatt turbines that last year got bought through a place called Broughty Ferry, which is near Dundee in Scotland, and they're going out to sit about 15 kilometres off the east coast of Scotland. And the yellow bits are just the bit that sit under the water. So the structure that goes on top of that is some 200 metres tall. And those are small ones, actually. Those are 10 megawatt turbines. We now have 15 megawatt turbines on the Murray West wind farm, and the Chinese OEM Mingyang is developing a 22 megawatt offshore wind turbine. Of course, all of this needs materials to be made. Lots of steel, lots of concrete, lots of copper to connect them to our grid. But actually, the thing about offshore turbines, in contrast to their smaller onshore cousins, is that in order to convert these massive rotational forces into electricity, we use things called permanent magnets. Now, these contain a large amount of critical raw material called neodymium. And we need a lot of neodymium to make all of these turbines turn. So we really need to plan now for how we're going to recover this material at the end of its life, and actually think about the fact that we're locking in that demand for the future. As Joan said, the decisions we're making now will last many decades into the future. So this is how we looked at it in the report. First thing is to think about infrastructure and technology planning, and it had a UK lens. Now, the UK, we're an island, and we're a really windy one. UK actually has more offshore wind resource that we can exploit for offshore wind than all of the next 5 European countries combined. So it does make sense that offshore wind will be a fundamental part of how we reach net zero and decarbonise everything in the UK. And we're aiming for 50 gig of offshore wind deployed by the end of this decade. And actually we're on track to have over 100 gig by 2050, which is some, depending on the size of them, 8,000 to 12,000 offshore wind turbines. And there's a move towards floating turbines, which will allow us to access deeper water, higher wind speeds. And indeed, offshore wind will be the biggest contributor to the GB electricity generation by 2050. But we have choices about how much energy we need. What mix of turbines do we put where? Some of them have bigger material impacts than others. Some need more concrete, some need more steel. All of them need neodymium at the moment, and we're not thinking about this. Believe me, as someone who comes from the renewables world, there is zero consideration of this. It's very easy to stick another zero on a deployment target and not realise how that translates into tons of real things. So we're urging for this to be a huge upfront consideration when we're making these choices. yeah, as I said, that's the size of one of these. There's a 12 megawatt nacelle. Those turbines are being made and deployed the world over at the moment, and that's just the bit that the blades attach onto where these massive magnets go. There's almost no consideration of end-of-life materials in the planning. And furthermore, if we're buying all of this resource into the UK, putting my UK head on for a second, isn't that a massive strategic resource that we're going to have into the future? We actually have our own urban mine of critical raw materials that we're bringing in by the shed load. So if we're deploying all of this offshore wind, we should start considering it as a material bank as well as a way to make electricity. This is a few pictures from my day job and trying to think about how do we design better to try and mitigate some of these issues. So we're trying to take apart the first wind turbines that were ever made about 30 years ago, coming to the end of life, very small onshore models. So the picture on the top right, that's actually some of my team trying to take apart a demonstrator scale, absolutely tiny, offshore wind stator that's jam-packed full of these permanent magnets. It's quite hard to do, actually. But there are some really consistent challenges coming through as we're taking apart these early models that I think we need to learn the lessons of for the future ones and design better. So there's no record of design or component composition. We're very lucky if we get any information about early turbines when they come in, let alone things like materials passport. No consistent standards, especially in the early models. And they were all made for low cost, and that is true today because the biggest single pressure on renewables developers is cost. So these problems have not gone away. In actual fact, they've got a lot worse in some cases. And the picture on the bottom left-hand side is to show some of the sort of differences in choices in a very practical way. So we've seen magnets that have been bolted in, and that's the right-hand side. So that allows for easy removal, repair, recycling. We love that design. But unfortunately, most of them are like the picture on the left-hand side, which is just whack it in with a load of epoxy glue because that's cheap and easy. How do you get that out at the end of life? The carbon contaminates the neodymium in the magnets, and it's just a complete nightmare. And it actually results in huge material loss. So that was just a practical example I wanted to show. Everything is cost-driven, but it's the upfront cost. It's not the long-term cost. So we have to design new assets with the end in mind, particularly with reducing demand for CRMs and then recovering them better. So the final thing we look at is circularity. Most wind turbines have a design life of 25 to 30 years. We've already started deploying offshore wind in the UK, so by the end of almost 2040, 1,000 offshore wind turbines a year are coming to their end-of-life decisions. We currently have no plan for how we effectively cover these materials. In order to do that, we'll need ports, we'll need vessels, we'll need skilled people. Again, believe me when I say no one is planning for this. Everyone is planning for this for the build-out of turbines. We're not thinking about how to get them back. And like I said, because they have critical raw materials in, they've effectively become a strategic resource for the UK and something that we'll need to think about long into the future. So the final slide, Isabella and Kane just asked me to present two different futures for what offshore wind could look like in the UK. The red crosses, no surprise, that's how it's going at the moment. So disregard for material demand in net zero planning. We're reliant on imports, we buy everything. We don't really recover materials very well. High raw material extraction and environmental impact. And this is a key one for me. We're so vulnerable to supply disruption. People think that renewables projects won't happen because they won't get planning or they won't get their grid connection. And I keep saying to them, what happens if you can't buy your turbine? What happens if we can't make enough? What happens if China says, sorry, you can't buy them from us? These are real prospects. We live in an uncertain world. It's not being planned for. So where we want to get to is with the green ticks. First of all, we only build what we need. That makes me really unpopular at renewables conferences, but I am passionate about that. We do not need to deploy more infrastructure if we can get our energy systems right. We need efficient materials recovery and recirculation. This isn't a one-time thing. Renewables are here for a long, long time, so we need to get better at having that closed loop plateau of demand. It would give us price stability. We would no longer completely exposed to huge fluctuations in critical raw material price. And it would guard the UK against the global shocks that I mentioned. So there are many different angles where the take-up of the recommendations we put in the report would actually help us towards what I think would be a better net zero than what we're currently headed for. So I'll stop there. Very happy to take questions on the panel with everyone else. And thanks.
If you don't mind joining us on the panel now, and I'll invite all our other panel members up. Great. So we're going to have a little bit of a discussion. I'm going to ask my panel members a few questions just to get a discussion between us, and then I'm going to open it up to the audience. And so, yeah, when you've got a question, or you probably have a few, I know there are a few already out there, just hold on to it. Then we'll come out to you and we'll ask a few questions in a go, and then I'll ask the panel members to address one or more of those questions. Okay, so but before I do that, let me just introduce you to some of our panel members you haven't met yet properly. So we've got Dr. Colin Church here, who's CEO of the Institute of Materials, Mining and Minerals and Mining, IOM3, known fondly as, a partner in the National Engineering Policy Centre, from which this report has arrived, and is a member of the working group who oversaw this report. He has held numerous positions advising government on risks associated with critical materials. Thank you, Colin. And on his left is Libby Peake, is Head of Resources Policy at the think tank Green Alliance. She's been at the forefront of thinking on the role of critical materials in climate policy for many years, and is one of the UK's most influential experts in the policy and politics of resources. And you've met our other two panel members already. So we have Joan and we have Charlotte. And I'm Mark. Okay, so I'm just going to kick us off and kind of just start with, there's so many recommendations in the report. How do we prioritize them? Is there a way to prioritize them? Is there a top of the list? If we're talking to policymakers or businesses, where do we place this kind of problem? We're trying to do everything at once, and that's probably impossible. Maybe I'll start with Libby, because you haven't spoken yet.
Not your report.
No. I do love the report, though. I'm so glad someone else is talking about demand reduction, because this is a subject that Green Alliance has been talking about for a long time, and it's been quite surprising that it hasn't got more traction. But I think that the most important thing is that we do start talking about socializing, I suppose, the idea of demand reduction, the idea that if you have a renewables-dominated future, it is a different sort of approach that you need to take to energy security. And I suppose actually this is probably true even if you're not in renewables, but the best way to achieve the three pillars that are typically held to be in energy policy of security of supply, sustainability and affordability, the best way to meet all of those three is to reduce the amount of materials that you need to reduce the amount of energy that you have to generate. And so it is baffling that hasn't been grasped more fully. So I think the most important thing is just to sort of land that conversation, and also to point out the fact that, as we've been talking about today, the UK is actually particularly at risk in a renewables-dominated future. Like that is something that is changing in the renewables-dominated future, because we are a resource-poor country. We currently import 100% of every single one of the 24 materials that have been identified as having higher elevated criticality. And with the exception, a few exceptions, notably lithium, but a few others as well, that's unlikely to change too much. And insofar as we are a resource-rich country, it's in the infrastructure that's building up around us. So it is going to be possible to get this right if we think about it now, if we plan now. But so far we haven't been. So it's great that more people are talking about it, and I'm really pleased to see this report out.
Thank you, Libby. Colin, so on that topic, so who does it need to land with? Does it need to land with policymakers, or does it need to land with business?
I think it needs to land with both of those communities. In the end, it's businesses that are going to have to make the decisions on the ground that impact on this. And as Charlotte said, there's limited evidence that thinking is happening at the moment. And that means that some of these companies are setting themselves up with real risks that they could already start to do something about. So there's already a bit of an incentive once they realise to do something. But then there'll be a limit to how much they can do within the constraints of our current setup. and starting to put in place policies that either enable or encourage that thinking is an essential step. So, for example, in the Contracts for Difference, there's talk about having sustainability criteria in those. So I'm going to bid to build a wind farm, and I have to say something about where my materials are coming from and what I'm going to do with them in the end. That's an example of something that, taken further, could start to really help in this space. And that's a policy push, but also a business handling, if you like. So, very easy answer, but...
Okay, thank you. Joan, do you want to say anything about this, like where the priorities lie? What's the first next big step? Like, what would you like to be, as a result of this report coming out, what's the first thing you'd like to happen?
The government to have a materials demand strategy. Because if you start with a strategy, you start to open up the conversation of what does the future look like. When people hear the word reduction,
Right.
MPs, companies, they don't like it, right? That's what you said. But if people can envisage a future that's positive and they can see how it's going to make a difference, then I think everything is better. You say, well, everybody can't have their own car. Sounds very negative. But if you paint a picture where it's actually a possible future, and we know those exist, then I think it gets better. But unless you have a strategy that's joined up across government, you don't get the policies that Colin said that we need. You don't get the requirement for keeping the materials here. And sort of aligned with that is the material bank, that we actually understand where our materials are.
Thank you. So Charlotte, is that kind of language of persuasion, which it feels like we're in that, like it's trying to persuade people to think about this differently and that everyone's going to win.
Mm-hmm.
But how do you do that? Because you've obviously done it within your company, you've done it at conferences, renewable. Like, what is the language that lands? Because obviously the reduction probably isn't the right word to use here.
Yeah. And just, I guess, deferring back to the question that was originally asked, I think it's policy that has to come first, because businesses only react when there's a problem, and this problem, or generally, hasn't come home to roost yet. So if you look at EVs, cobalt was used quite extensively in the first generation of the batteries, but then Tesla saw how volatile and uncertain and that the supply had bad connotations, and so they started designing it out. But the problem was there first. So the Contracts for Difference example that you gave is a good example of where policy can kind of get in front of that and influence positive behaviours. But actually, what change would I like to see, and how do you persuade people, is number one, you have to have that basic recognition that everything is made from something. It's as simple as that. There is so many people who exist in the renewables world where that is not a day-to-day consideration. Or if you say that turbines have to be made from something, well, they're made by someone else in a different country, and it's not our problem. Our problems are planning, grid, local communities, but we have to make it relevant. And we've highlighted that there are opportunities for this kind of better future and a thriving circular industry. That's what makes it real, but it does come back to the crux of we're quite bad, aren't we? We all forget that things come from somewhere. It's easy to go and buy a new washing machine or a new mobile phone and not think about where it comes from. Wind turbines are no different.
I mean, I'm going to come to the audience in a minute, but when I've talked about this, I within an engineering framework, sustainability, everyone is in agreement. But then an economist comes from the outside and they'll say, yeah, but your neodymium is going to be worth a lot of money and the price will just go up to the point where it's actually worth getting it out of there, and the company will react to that. And so basically, that's how we've always done materials. When there's a shortage, the price goes up. And why won't the market work here is the question that they always say. They say the market will work. You're just kind of raising alarm. Is there a good answer to that?
I think there are a couple of things to say in that space. So firstly, that definition assumes that the market is operating as a proper market. And certainly with some of the critical materials, the geopolitical context might mean that isn't the case. So you may have price shocks that come along because of other actions, and the market won't necessarily adjust, because the other side of that argument is you would also expect supply of virgin materials to increase. But we know that doesn't necessarily happen. So it's not a free market. Those arguments don't necessarily fully work. And the UK is not necessarily in the best place to buy the stuff. We are no longer the richest country in the world. We are no longer the biggest economy in the world. We no longer have the biggest navy in the world. We can't go around and say, "Oi, give me that stuff now for a decent price." We are competing with other countries who have more, whatever that might be. And so even if it is operating as a free market, we might not be able to take advantage of it. And then I guess the other thing is that it's the grey old one. We don't internalise our externalities enough. So the market price that you pay for mining something probably doesn't fully take account of the environmental and social cost that's imposed on the community where it is being mined. Sometimes it might, but often it won't. And so if you want to take a more holistic view, you need to worry about that. And so that price signal isn't the full price signal.
And does everyone agree with that? Any things that...
Yeah, I do agree with that. I mean, a very real example is that the magnets we recovered from that wind turbine, the only place that wants to buy them is the US at the moment. We don't have capacity to recycle them in the UK. And as a recycling company, we sell to who wants to buy. So yes, on a pure economics argument, maybe, but the playing field is not level, and we are so far behind in the UK at the moment. So again, putting the UK head on, and again, then you kind of throw in the just transition argument. It'll only be the rich countries and those who've got their act together that can act first. So then you get a huge disparity in who can access these materials. So that's just a reflection on that point.
We have a huge opportunity in the UK to bring jobs to the UK if we actually move ahead and start to think about the infrastructure we would need to do the recycling. Because as you say, at the moment, are we going to build it first? Well, we know if we leave it to the last minute, we won't be able to build it first. We've seen that with lots of things during COVID, with masks. We've seen it with none of us could get computers. We could hardly buy cars because we've offshored all of our computer chips. Other countries are much more able to rapidly deploy when prices go up than we are in the UK. And that also leaves us at all these political issues. Now, in a company, when you make decisions as to how long, if you're going to make a capital decision or an infrastructure decision, you're looking at a payback of 2 or 3 years, maybe 5, not 20 or 30. So that's where government policy has to come in, because it'll be like the last 30 years where manufacturing has left the UK because we didn't have a strategy. And that's why I really think it needs a joined up strategy across government to take charge of the opportunities, but also make sure these very significant risks don't get completely ignored. And if you look at, if mining and recycling, we have safety and ecological, environmental regulations in this country, which makes it more expensive than it does for other countries. Now that's right. However, we need to act in a way that doesn't cripple us against foreign competition.
Thank you. And Libby?
I suppose I agree with everything everyone said, but to put some figures, a bit of colour on it. When we did a bit of digging recently, we found that in China, they've already got, as of 2022, 61 lithium-ion battery recycling plants. In the EU, they have more than 20. And in the UK, we've just opened our first one. And a lot of that is down to the fact that we haven't had the government strategy that's willing to make the sort of demands on businesses to intervene in the way that you need them to in order to see that technology develop here. And I suppose just a comment again on the market side of things. I'm not sure if I don't think this is an argument that economic rationality will win out. But I think to add to Colin's point about the externalities not being factored in, I think historically we've always seen that that's the case. But there's no way in which that can always be the case. And so the Green Finance Institute has been doing some research into degradation of UK supply chains and the impact that that's going to have on the economy and the economy's ability to grow. and they found that the degradation in supply chains is likely to have an impact of hitting GDP by 6% by the mid-2030s, which is the same hit that you took in the global financial crisis. So I don't think that's I'm not saying leave it to the market because of that, but I am saying like things will start to get worse. It will start to bite more.
Thank you. Okay, I'm going to ask for questions from the audience, and then sort of just if everyone puts up, we'll go around and just get the questions out in the air, and then I'll come back to the panel. So there's a question there, and one behind, and one here. Yeah. Did you see those? Yeah, these three, and we'll get everyone just to say their question, and then we'll come back to the panel. Thank you.
Okay.
My name, yeah.
Yeah, my name's Terry Spall, the 135th president of the IMechE. I think we're on 138 now, so I'm just a few years out of office. And as of the last 3 weeks, I've been a fellow of the Royal Academy, so thank you very much. Something Joan said just started me thinking actually about where we are in the UK and about electric vehicles in particular, because the cars that are sold on the streets, 80% of them are imported. So our influence on those is a little bit restricted. So if we want to influence demand side, I mean, is there an opportunity here to connect these things together? So if you look at what's happening now in America, they've got massive tariffs on electric vehicle imports from China. If the Republicans are successful, then it's going to go up to about 200 to 500% tariffs on vehicles going in from China. Europe's got tariffs on vehicles coming in from China. We haven't yet. But are tariffs the right mechanism, or could we be much smarter and actually tie it to what's going on here? So we have a much more ethical stance on applying tariffs because they're actually based on the usage of critical materials, considering recyclability and all these other factors. So it's not just a straight financial tariff. It's actually an ethical stance that we want vehicles coming into this country that have really good demand-side uses of critical minerals. And just an extension of the question, if I may, just because I'll not get the microphone again, I don't think, is we've talked about supply of critical minerals quite a lot. And yes, we've got potentially lithium to come from Cornwall, and that'd be fantastic. But the other critical minerals that we need in great abundance, we don't have. Or do we? Is the question I want to pose, because polymetallic nodules that sit on the ocean floor are there for everybody to extract. Now, I've asked this question a few times at conferences, and I get an amazingly slavish answer that says ecologically and environmentally it's too difficult. It's a non-starter. But if you follow what's happening in America now, they're actually doing something called nodule collection. It's not actually extraction, because these things sit on the ocean floor, and they're using AI technology so that when a probe goes down, it actually looks at each individual nodule and it works out if there's any biological activity on it. If there is, it doesn't collect it. If there isn't, then it will collect it, and it's taken off without creating any disturbance to the sediment. So it can be done. Right now, whether we like it or not, I think China is going to do this in a slightly less elegant way, and we'll probably buy those minerals that they extract. So why are we not doing it? We're great at marine engineering.
Okay, thank you. Dawn is here, and then there's a question just behind. Yeah. Oh, yeah, you go.
Okay. Dawn Bonfield. So I'm a materials engineer, and I'm from King's College London, and very keen to see the design skills recommendation and how we pass that on to the next generation of engineers. But the question was about really, we've made a set of recommendations from our sector to the government, to policymakers. How have they responded? Because I know that you have engaged with them as stakeholders. So what do they think of this, and will they make any changes? Thank you.
Thank you. And then one more question just there.
Hi, I'm Neil Whitlam from Innovate UK. So I'm just interested, there's been hints at the kind of international aspects of this, and most of the supply chains of the big equipment shown in automotive are international supply chains. Even if we had perfect kind of circular system in the UK tomorrow, it would only really cover, I think, a fraction of our needs for these kind of metals. So, yes, I think everybody would love policy alignment across government, including Innovate UK, I think. But what should we be doing internationally? How can we use whatever influence we have to change the kind of international environment on these materials?
Thank you. Okay, I'm just gonna let the panel pick one of those questions each, because we have run out of time, unfortunately. So we've got tariffs, ethical tariffs. We've got nodules on the ocean floor. We've got what is the government's response to this report? Do we have any feedback already or engagement? And what's the international dimension? If I start with Charlotte and then I'll move back this way.
Ooh, I get first choice.
Everyone gets a.
Okay.
How about that?
Well, I'll take the last question if I may. Sorry.
And it will have to be quite short answers.
That one. No, go on.
Okay.
And all the time we have to. Sorry, but we're.
No, that's fine. Yeah, definitely take your point. The demand we need far outstrips the supply we could get from circularity for many decades to come. So we do have to get our heads around this uncomfortable truth. We need it to come from somewhere. I think whatever our choices are, the first bit is missing, which is people haven't got their heads around and government haven't got their heads around that bit. We're doing things unconsciously. Even if we do the same things consciously, that is better than not knowing why we're doing them. So that maybe does or doesn't answer that. But I think, Libby, you probably should get a stab at that one just as well.
Yeah, I'd love to have a stab at that one. I do think that that's a really important point. And what we've observed is that everybody is talking on an international stage, as insofar as they're thinking about it, they're thinking about supply. And so everybody is trying to look around and shore up their supply of materials, which leads to dangerous prospect of stockpiling, where these become even harder to obtain, and also of bringing on more and more types of supply that potentially have really serious ramifications for the environment and for society. And I would include nodules in that. I'm not sure that the evidence is there yet that those are fine, and I think that does really speak to the need to get the international community thinking more about demand reduction rather than just supply and how it can serve everyone's needs to do that. And I think that the UK government has a real opportunity, and potentially we're hoping that there's going to be a way in for that, because they want to be back on the world stage. They want to launch this Green Power Alliance. They want to play a big role in the climate conferences. And those climate conferences do occasionally talk about critical raw materials, but not very much. And it should form a key part of climate diplomacy. So I think that there's a lot to be done on that front.
Thank you. Colin.
I'd like to answer the same question. I probably shouldn't.
Well,
just on the point about ethical trade tariffs. I mean, I think there's a really big question about whether trade tariffs work at all and how they work, and there's lots of conversations about that. There's also an issue about whether, in fact, what we want is cheap electric vehicles. That's what we need for the transition, and therefore why should you be making them more expensive and mean only those people who can afford a Tesla get one? There's also the question, though, of how you would judge those ethical standards, and I think that is really quite difficult. The further down that supply chain you go, the harder it becomes to trace materials, for example. So quite often materials will be mined in one place, shipped somewhere else for processing, and that place that does the processing might have materials from multiple mine sites and then might send it out to multiple customers. And so that blending and mixing means it's very, very difficult to track one atom of copper all the way through and say this atom is ethically mined and this atom is not ethically mined. And you therefore have huge scope for fraud. So I think you can have conversations about levels of that, but tariff on the basis of ethical, I think, is quite a difficult thing to do. It's almost certainly probably in contravention of our WTO obligations as well, but that doesn't seem to matter to anyone anymore. So.
Thank you, Colin. And Joan, finally.
What's left?
Yeah, well, we've done ethical tariffs. We've done a little bit of nodules on the ocean. We've done international policy. Yeah, you're very well positioned to answer whether who have we been talking to in policy and how have they received this report?
This is the point at which we asked Kane to come.
So we have invited and had discussions with various members of different organisations and government. We've had feedback on the report, which has been very positive, but I think that's our next steps, is to push that through. And if I can have just the last word on nodules on the ocean floor, since it was the first question. We know we can do anything we turn our heads to, especially when the need is there. We just need to look at war and wartime and the innovation that happens. But I think what sets Britain apart is our want to do it ethically, and also because we want to do things on the back of good science. So if we want to mine the ocean floor just as much as fracking or anything else, I think we need to do the science to say, how do we do it and how do we do it ethically? Because if I know anything from being in the chemical pharmaceutical industry or being a process safety person, is that we know somebody will always find a way around it. Grenfell's a great example of that. So we lead the world in science in this country, so why don't we lead in looking at what's the safe way to do that, what's the ethical way to do it, and what's the ethical and safe way to move towards net zero? Because I don't want to be in a world where in 20 years' time, my children or my grandchildren can't afford to live because they're not wealthy enough to afford a Tesla. And I think engineers have the responsibility to shape, because we know we can, our future. And as Charlotte very well put, if we don't do something today, the future's already written, and it'll be China and it'll be America, and we'll be fighting. And we could make UK a powerhouse again. And, read Ed Conway's Material World Book to see just how much change we can have if we get ahead and actually have a joined up strategy. Thank you very much.
Thank you, Sharon. Thank you. Okay, well, that's your panel. And now, just finally, Joan is going to do a few closing remarks.
Well, thank you all for coming. I really encourage you to read the report. Please share it with anyone you think can make a difference. Let's have this conversation. Let's socialise all these points. If you think there's anybody we should be talking to, please let us know. And a huge thank you to Kane and Isabella and the Royal Academy team. Thank you to the panellists and to the committee for the huge amount of work that's gone over the last year. And hopefully this is the start of many conversations that will make a difference. Thank you very much, Chair.